Next topic, determination of describing function of saturation nonlinearity. We know that saturation nonlinearity is a nonlinearity in which output is proportional to input up to a particular value. After that, the output is constant. That type of nonlinearity is called saturation nonlinearity. Here, the saturation nonlinearity input-output relation is shown in this figure. Here the x-axis represents x and y-axis represents the output y. Up to x is equal to s. Up to x is equal to s, the output is linear. After that, when x greater than s, the output reaches a saturated value, and the saturated value is ks. That is y is equal to mx. Therefore, here slope is equal to k. Therefore, m becomes k, and that is ks. Okay, is it clear? This figure shows the input-output relationship of a saturation nonlinearity up to s, that is up to x is equal to s. The slope k here, this is a linear relation. After when x greater than s, this reaches a saturated value. The output reaches a saturated value. Next, for explaining the describing function, consider the input signal to the nonlinearity is x is equal to x sine omega t. That is x is equal to x sine omega t, and capital X is the maximum value of the input. This shows the sinusoidal response of saturation nonlinearity. Consider up to x is equal to s, this is linear, that is it's linearly increasing. Similarly, the sinusoidal response with linear increases up to this value beta. Okay, when x greater than s, it is saturated. That is, here if greater than beta, it is saturated up to pi minus beta, and again pi minus beta to beta, it's linearly decreases. That is a sinusoidal response. That is, up to 0 to beta, it linearly increases, and beta to pi minus beta, it is saturated, and pi minus beta to pi, it's linearly decreases. It is a sinusoidal response of this saturation nonlinearity. Then consider when input x is sinusoidal, we are applying the input to the nonlinearity is sinusoidal, that is x is equal to x sine omega t. Consider when omega t is equal to beta, that is in sinusoidal response, this x-axis represents omega t. When omega t equal to beta, this x is equal to s. From the figure, it is clear that omega t is equal to beta. That is up to this linear portion, the value of x is equal to s. That is omega t is equal to beta, x is equal to x. Substitute this condition in this, x is equal to x sine omega t. Therefore, this is rewritten as substituting x is equal to s. Therefore, s is equal to x sine beta. Omega t becomes beta. Therefore, sine beta is equal to s by x, or beta is equal to sine inverse s by x. That is, in the case of saturation nonlinearity, sine beta equals s by x, or beta is equal to sine inverse s by x. Then, from this figure, it is clear that it exhibits both half wave and quarter wave symmetry. Is it clear? It exhibits both half wave and quarter wave symmetry because its value up to 0 to pi and pi to 2 minus 2 pi, it exhibits half wave symmetry. The value up to 0 to pi is the mirror image of pi to 2 pi. Therefore, it exhibits half wave symmetry. And it also exhibits half wave symmetry. That is 0 to pi by 2 equal to pi by 2 to pi. So, it exhibits quarter wave symmetry. Then we need to find the value of output y. Then consider the output y, that is y is equal to up 0 to beta, 0 less than omega t less than beta, its value of y is equal to kx. That is, in this range its value is slope is k, and this range its value is x. Therefore, y is equal to k into x, that is y is equal to mx. Here slope is equal to k, therefore y is equal to kx. Next, from beta to pi minus beta. Beta to pi minus beta is at this range. At this range, its value is k into s. That is, at this point, its value is s. Therefore, slope is k. Therefore, it's become k into s. And again, pi minus beta to pi, it's again k into x. That is, its value is 0 less than omega t less than beta, its value is kx. Beta less than omega t less than pi minus beta, it's ks. And pi minus beta less than omega t less than or equal to pi, its value is k into x. That is the range of y in this region. We need the range of y for finding the describing function. Next, we are going to derive the describing function. We know that describing function is equal to kn of x omega equals y1 by x angle phi 1, where y1 equal to root of a1 square plus b1 square and phi 1 equal to tan inverse b1 by a1. From the figure, it exhibits half wave and quarter wave symmetry. So we need to integrate only from 0 to pi by 2 because it exhibits quarter wave symmetry. So we need to integrate only from 0 to pi by 2. Therefore, a1 equal to 2 by pi by 2 to integral 0 to pi by 2 y sin omega t d omega t are same as that of dead zone nonlinearity. In the case of dead zone also, it exhibits quarter wave symmetry. So we integrate 2 by pi by 2 to integral 0 to pi by 2 y sin omega t d omega t, and b1 equal to 0. It exhibits half wave and quarter wave symmetry. Therefore, b1 equal to 0. Therefore, the equation of a1 becomes 4 by pi, 2 by pi by 2. That's become 4 by pi into integral 0 to beta. This 0 to pi by 2 range is splitted as 0 to beta and beta to pi by 2. That is 4 by pi into integral 0 to beta y sin omega t d omega t plus 4 by pi into beta to pi by 2 y sin omega t d omega t. It is splitted because the value of y for 0 to beta and beta to pi by 2 are different. So we integrate from 0 to beta and again from beta to pi by 2. We know that up to 0 to beta, its value is k into x, and from beta to pi by 2, its value is k into s. So substitute the value for y, here k into x and here k into s. Therefore, the equation becomes a1 equals 4 by pi into integral 0 to beta, y becomes kx sin omega t d omega t plus 4 by pi into beta to pi by 2 ks sin omega t d omega t. Then substitute small x is equal to capital X into sin omega t. Here it's become capital X into sin omega t for this small x. Then it's become 4kx by pi into integral 0 to beta. From this, x is taken outside the integral. Therefore, 4kx by pi into integral 0 to beta sin into sin square omega t d omega t plus 4ks pi into beta to pi by 2 sin omega t d omega t. For integration, sin square omega t is rewritten as 1 minus cos 2 omega t by 2. Okay, and this 2 is taken outside the integral. Here it's become 2kx by pi into 2kx by pi. Then substitute then do the integration. Therefore, 2kx by pi into, here it's become omega t minus sin 2 omega t by 2. That is, integral of cos 2 omega t is sin 2 omega t by 2, 0 to beta plus 4ks by pi into integral of sin omega t is minus cos omega t into beta to pi by 2. Beta to pi by 2. Therefore, 2kx by pi into beta minus sin 2 beta by 2 into 2 sin 2 beta by 2. Substituting for this plus 4ks by pi into minus cos pi by 2 plus cos beta. Is it clear? Then again here it is 0, therefore no need to substitute the value. Therefore 2kx by pi into beta minus sin 2 beta by 2 plus 4ks by pi into minus cos pi by 2 plus cos beta. We know that cos pi by 2 is 0. Therefore the expression becomes 2kx by pi into beta minus sin 2 beta by 2 plus 4ks by pi into cos beta. Next, substituting, we know that s is equal to x sin beta. From the first we get sin beta is equal to s by x, or s is equal to x sin beta. Here we substitute s is equal to x sin beta. Therefore the expression becomes 4kx by pi into x sin beta cos beta equals 2kx by pi into beta minus 2 sin beta by 2 plus 4kx by pi into sin beta cos beta. Then 2kx by pi into beta minus, here sin 2 beta becomes 2 sin beta cos beta. Sin 2 theta is equal to 2 sin theta cos theta. Therefore sin 2 beta is equal to 2 sin beta cos beta. 2kx by pi into beta minus sin beta cos beta. 2 and 2 get cancelled. Therefore beta minus sin beta cos beta plus 2 sin beta cos beta. Okay, is it clear? From these both two equation, 2kx by is taken as common. Therefore 2kx by pi into beta minus, here 2 and 2 get cancelled, sin beta cos beta plus, here 2kx by is taken as common, remaining 2, that 2 into sin beta cos beta, that is equals 2kx by pi into beta minus sin beta cos beta plus 2 sin beta cos beta is equal to sin beta cos beta. Therefore it's equals 2kx by pi into beta plus sin beta cos beta. From this we got a1 equals 2kx by pi into beta plus sin beta cos beta, and also we know that b1 equal to 0. Therefore y1 equals root of a1 square plus 0, that is equal to a1 equals 2kx by pi into beta plus sin beta cos beta, and phi1 equals tan inverse b1 by a1 equals tan inverse 0. Therefore describing function is equal to y1 by x angle phi1. We know that y1 equal to a1, that is equals 2kx by pi into beta plus sin beta cos beta, and phi1 equals tan inverse b1 by a1, that b1 equal to 0, that is equals phi1 equal to 0. Therefore the describing function becomes, by substituting for y1, 2kx by pi by x. Therefore this x and x get cancel. Therefore the equation becomes 2k by pi into beta plus sin beta cos beta, and the value of angle is 0. Therefore kn of x omega equals, that is describing function of saturation nonlinearity, equals 2k by pi into beta plus sin beta cos beta, or it is written as 2k by pi into sin inverse s by x plus s by x into root of 1 minus s by x the whole square, because sin beta equal to s by x. We derive it, sin beta is equal to s by x. Therefore beta is equal to sin inverse s by x plus s by x into root of 1 minus s by x the whole square. Therefore describing function of saturation nonlinearity is 2k by pi into beta plus sin beta cos beta, or 2k by pi into sin inverse s by x plus s by x into root of 1 minus s by x the whole square. That's all about describing function of saturation nonlinearity. Thank you.